Building fairness into generative AI is a strategic imperative, not an afterthought. It requires intentional design and incorporating diverse perspectives from the outset. Our goal is to explore practical strategies to reduce bias, develop robust measurement metrics, and ultimately create truly inclusive AI systems that serve everyone equitably. Bias can enter AI systems at multiple stages, during data collection, algorithm design, and deployment. Addressing it requires a structured approach. We must first identify bias patterns, then measure their extent using established metrics, and finally apply mitigation techniques to reduce harmful impacts. This cycle is fundamental to responsible AI development. Understanding where bias originates is crucial. Key sources include training data bias, which reflects historical inequities, algorithm design bias, where models amplify existing patterns, development team bias, stemming from limited perspectives, and deployment context bias, where real-world application reinforces disparities. Each source presents unique challenges. Quantifying fairness requires specific metrics. Concepts like demographic parity assess whether outcomes are independent of sensitive attributes. Equal opportunity focuses on ensuring equal performance for different groups on specific tasks. Counterfactual fairness considers whether an outcome would change if a sensitive attribute were different. These metrics provide essential visibility. Measuring representation helps us understand how models perform across different demographic groups. It reveals if certain communities receive less accurate or appropriate outputs compared to others. Tracking representation scores against benchmarks is a critical diagnostic step to identify disparities and target mitigation efforts effectively. An inclusive development process is key to mitigating bias proactively. This involves assembling diverse teams, ensuring representative data collection, incorporating participatory design with affected communities, and conducting iterative testing specifically for bias across groups. This holistic approach builds fairness from the ground up. Various technical techniques can help mitigate bias. Pre-processing methods focus on cleaning and balancing training data before model training. In-processing techniques modify the learning algorithm itself to enforce fairness constraints during training. Post-processing methods adjust model outputs after training to achieve fairer results. Establishing robust community feedback systems is vital. This means actively collecting input from diverse communities, analyzing patterns in that feedback to identify recurring bias issues, and implementing changes based on what we learn. Continuous engagement helps uncover blind spots and drives ongoing improvement in system fairness. As AI fairness becomes a global focus, regulatory considerations are increasingly important. We must adhere to emerging AI fairness regulations, proactively assess potential harms from biased outputs, and prepare for upcoming fairness certification requirements. Staying ahead of the curve is essential for responsible deployment. Our path forward involves setting clear goals and metrics. This includes aiming for comprehensive coverage across user groups, establishing parity goals for key outcomes, and implementing regular review cycles to monitor progress. Building fairer AI is an ongoing journey requiring commitment and continuous effort.